Bismillahirrahmanirrahim. Hello guys, my name is Abdul and I am the student of BS Environmental Sciences, B. Marilisha, Aries University, Rawalpindi. Today's my topic is about decimal to binary conversion, means the conversion of numbers from base 10 to base 2. Let's start. Table of contents. First of all, I will discuss about the number system, then decimal and binary number systems. Then I will discuss rules of conversion and then conversion of fractional parts. Number system. The number system or numerical system is the system of naming or representing numbers. There are various types of number systems, binary number system, decimal number system, and so on. The value of any digit in a number can be determined by three factors: the first digits, and the second its position is, and the third the base. These three factors are the main factors on which the number system can be divided into four main types: binary number system, octal number system, decimal number system, and hexadecimal number system. The decimal numbering system we are most familiar, which have a base radix of 10, and to us this is natural. Decimal number system. In this number system, the numbers are presented with base 10. It is also called the base number system, base 10 number system, which consists of 10 digits such as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and no more. Each digit has a specific position, and each digit is 10 times more significant than the previous digit. Suppose we have example to explain it. 25 is a decimal number, then 5 is at tens place, and 2 is at 5 is at units place, and 2 is at tens place. So 2 is 10 times more significant than 5. More examples. Some examples are 12 base 10, 345 base 10, and so on. Each value in this number has the place value of power 10. Yes, it means that digits at the 10th place is 10 times significant, as we discussed earlier. Let's see some more examples. Positional is also called positional number system. Have different positions such as 92 base 10. First example, 200 base 10. Second example. In first example, 2 is at units place, and in second 2 is at hundreds place. So 2 is different at both places, having different values and weightage. Means positions is different. The decimal numbers which have digits present on the right of the decimal denote each digit with decimal decreasing power of 10. Means if we have example 30.2 base 10. At the right side of the decimal, 2 into 10 is power minus 1, means decreasing power of 10. How we write decimal digits? We all know it has 9 character. It has 10 characters from 0 to 9, and if we take example 4872, then 2 is at ones place, 7 is at tens place, 8 is at hundreds place, and 4 is at thousands place. So we can write it as 4872 D or 4872 base 10. Binary number system, they count with the digits by 1 and 0, and these are more significant and simple numbers used by computers, and this is also known as base 2 number system, and this is used in all modern computer digital devices. Example is if we convert binary decimal to binary, such as 250 is decimal number, and then its conversion into binary system is 11111010. More examples. How many digits does binary have? We already know binary has just 2 digits, 0 and 1, and we also represent it in form of 0 and 1. We make it also uses same rules as the decimal number system. We make the right digit 0 and add 1 to left, then our next number is 10. Examples of binary number such as 1011, 101, 011, etc. Each digit in binary number is called a bit. Why we use binary number system in computers? Computers represent information in the form of binary digits 1 and 0. So this uses binary number system. And computer uses voltage, but voltage can change, and no specific voltage is set for each number in the decimal system. So for this is the reason binary is used and is made as two-state system, means on and off. Usually off means 0 and 1 is written as on. Binary number system. Now we will discuss significance of decimal number system. Decimal number system is base 10 number system, and it is also positional value system, means as we discussed earlier, it has a different each number has different position and different values of weightage. So let's take example. In first example, 7 is at hundredth place. Second 7 is at first 7 is at thousandth place. In second 7 is 10th place, and in third 7 is at units place. So all have different weightage of each position. In digital system, instructions are given through electrical signals, yes, and so various variations can be take place by varying the voltage of signal. Having 10 different voltages to implement decimal number system in digital equipment is difficult, so we mostly use binary number system because it is simple and uses only two digits, 1 and 0. Rules of conversion. Basically, binary is the basis for binary number system is the basis for all binary codes and all digits for data storing and used in electronic devices. The two main rules are division and multiplication. If we convert decimal to binary number system, we must have divided that number by 2. And if we convert binary to decimal number system, we must have multiply with 2 of power n. Let's have an example with if we convert binary number into decimal number, such as 1010001 base 2. If we multiply it with 2 of power n, then we get decimal 121 base 10. If we reverse this system, if we reverse this 121 base 10, if we divide it by 2, then we get binary number 1010001 base 2. So no confusion. If we convert binary to decimal conversion, same is the case. We must have multiply. We must have multiply with base of base with 2. Each binary digit has multiplied by decreasing power of 2. Next, let's take an example to understand this. 11011 base 2. We need to multiply each binary digit with a decreasing power of 2. So we will multiply and will sum of all digits, then we get 27 of base 10. Next, decimal to binary conversion. To convert decimal number into binary conversion, we must have divide by 2 until the coefficient is 0 and no more division can take place. So then the remainder which is obtained will be written in order of LSB to MSB, means least significant bit to most significant bit. Let's have an example. 26 of base 10. Let's convert into binary number. First of all, 26 must divided by 2 and so on till the coefficient is 0, and then the remainder can be written as 11010 base 2. Give a decimal number system. We have another example. To convert 25 into a binary number, we must have divide it by 2, and the remainder we will write is as 110012. Conversion of fractional numbers. First we will discuss decimal fractions. Let's look at an example using decimal number 345.678 base 10. As you know, when we write a number in decimal, we can break it down into a number of different components. As in this table, the equivalents, we have equivalent and other numbers of decimal fractions. As we saw with integers, we have different columns on the left hand side of the decimal point. These all represent different components of the integer part of the number. The decimal numbers which have digits present on the right side of the decimal denote each digit with decreasing power of 10. So we can say as our exponent becomes negative, it means we get fractions, and in the case of decimal, this results in the tens, hundreds, thousands, and so on. Actually, we can write the negative power of base as 1 divided by 10, 1 divided by 100, 1 divided by 1000, and so on. binary fraction. So getting back to our example, if we want to if we want to take look through binary fractions, we will have an examples and first break it down into constituents. This is table having equivalent numbers and other numbers also. So this is the same as after decimal numbers. So this is same as the decimal numbers. The decimal numbers system with decimal numbers which have digits present on the right side of the decimal. Denote each digit with decreasing power of 10. And these are the examples. Let's take a look. And the negative power means we can write it in fractions means 2 power negative 1 means 1 divided by 2. We can write it as so. Next we will move. This is the table for number system codes, and this is just convenience. You can have this. Next I have written some tips for you guys to better understand the conversion. First of all, opposite conversion for easiness. It means when we convert binary digit into decimal in the opposite direction, it will have more convenient to learn. And calculator conversion by using Windows 10 etc. The calculator that comes installed with Windows 10 can do this conversion for you, but as a programmer you are better off with a good understanding of how this conversion works. So the calculator's conversion options can be made visible by opening if we open its view menu and selecting programmer. Then more practice through some examples. Let's take examples and then start conversion. Try converting first decimal number system into binary number system, and then binary number system decimal with examples. This will be more convenient for you guys. That's all. I hope you are understanding me. And if you have any questions, you can ask me freely. Thanks for watching.